We're going to look at an exam question. We're going to look at an exam question in analytical geometry. And let's just get started. It says in the diagram that E and F are the x and y intercepts of this line here, which is 3x plus 8. Y equals 3x plus 8. There's another line through B that goes through B and A and M, and that hits a point 1 and 5. It goes through the point 1 and 5 right there. It makes an angle of 45 degrees with this other line, and it cuts the y-axis. It has a y-intercept at M, right there, right at M. Well, let's just get started. Let's try and do this thing. Determine the coordinates of E. The coordinates of E. So here's the first one, the coordinates of E. First, you have to look at E and think, well, what the heck is that? First, it's on this line, y equals 3x plus 8, and that E is on the x line here, the x-axis. So it's an x-intercept. And what do you do with an x-intercept? You let y equals 0. Well, that's the key. Now you just subtract 8, you divide by 3, and you've got it. You've got the x-intercept, minus 8 over 3. But you don't have the answer because they asked for the coordinates. So you have to write, the coordinates are minus 8 over 3 and 0. Those are the coordinates of E. Let's try the next question. Determine the size of this angle DAE, this angle way down here. We know that's minus 8 over 3 right there. What's the angle down here? Well, I don't know. That looks, well, we've got this is 45 degrees. We don't know. How are we going to get this angle right here? Well, you know, if you see 45 degrees here, you probably see right away that this angle on the other side, is 45 degrees. So I could write that in right there, right now. You know, that's a long ways to getting the answer there. A long ways to getting the answer. I want to cover that up because I haven't got there yet. That's 45 degrees because of vertically opposite angles. You got to put the reason there. Now you've got this angle. How are we going to get this angle? Well, if we knew this angle, we'd be set because these two angles are called opposite interior angles. This is an exterior angle. We could just take this angle and subtract that and get that. But how do we get this angle? Well, that angle is called an angle of inclination. And if we have the gradient of this line, we could ask our calculators what the angle of inclination is. We just go shift tan, and it works. Well, do we have the gradient? Yes, we do. We do have the gradient of this line. It's the number in front of x. You just have to learn it. The number in front of x is the gradient. So if we go shift tan of the gradient, we get this angle in here, which is 71.6 degrees. That's the angle of inclination. Well, now we've got the angle of inclination. We got this, which is also the exterior angle of this triangle, which is DAE. We can figure out this angle now. These two angles have to add up to equal 71.6, so we just subtract them, and we're going to get our answer, which is 26.6 degrees. And the reason is the exterior angle of triangle ADE. Well, that was quite a bit of thinking, just doing those first two questions. So I think I'll leave it there, and we'll do the rest in the next, maybe the next couple of videos. I think that might be a good idea.